Hello student, I am Arnab Das. Today we discuss about the cyclic code, which is basically defined by the capital C. Cyclic code is a linear code, and for the cyclic code, if any cycle shift of a code word is also will be defined as a code word. That means if any code word is written as a form of A0, A1, A2 up to AN minus 1, if it is a n-bit code word length code, that time for a single shift, if the signal or code word is come as such, that is the AN minus 1, A0, A2, A3 up to AN minus 1, that time that one also will be defined a code word for the C. So this is the two important thing should be remembered for representing a code which is belonging in the cyclic code. Let's take an example so it will be easy for understand also. Let the binary code is C1 and the code words are as I say this is the 000, 0101, 1010 and 41. So look that there 000 if the 0 is come at the again at the first bit position, that is the MSB is come now the next MSB position, so that time it will be maintained as value of 0. So this will be create the same code word. If you think for the another one, let the second for the bit the value is given as a 0 1 0 1. So if you shift or rotate, that time the value will become 1 0 1 0. So this one also an bit or code word for the C. Look at this is the 1010. If you consider for the 1010, that is for the third code word which is written on that particular formation. So if you shift or rotate for a single bit, that time the value will become 0101. So that one also will be present at the C. So this C1 will be treated as a cyclic code. Now, for the another one example, let the cyclic code for the C2 is given as 000, 0110, 1001 and 41. So from here you can check that 0 can be considered as such for the code word. But if you think for this one, that is the 0110, if you rotate this one for a single bit, that time the value will be 0011, which is not present in this code word. So C2 is not represent a cyclic code. Okay. Now for the linear code, which is different for C, which is stated initially, C is also will be the linear code. So here the condition will be that for the linear code should be two code word sum belong the code word. Look that if you consider for the C1, if you consider for the C1 the example, if you added between the two code word, that is the 0000 at the first and the second one is given on there 0101. If you add between them, that time the value will become 0101. So this is present addition or sum is present in this code. If you consider between the addition of 0101 with also say a third one code, that is the 1010, the result will become 1111. So that one also present at that particular C1 code. So C1 will be defined as a linear code, that is the sum of two code words belongs to the code. Now the second one is given that all zero code word is also or always a code word. That means each and every bit one also will be defined a code word. So in here for the C1, each and every element is has a apply 0, and that one will be specify also a code word. So for the linear code, the feature or condition is fulfilled in here. Third one is that minimum Hamming distance between two code words of a linear code is equal to the minimum weight of any non-zero code word. So if you think for the non-zero code word here, this is the 2 is the weight. Here also it is 2. For this one it is 3. So minimum one is the 2, and inter between any two code word, there the Hamming distance is as a 2. So here the condition for the 3 is also fulfilled. So obviously you can identify that the cyclic code, by using this kind of feature, it should be follow the linear code. And second one, for any shift of any code word is also a code word. Okay, so these are the ultimate thing when you talking about the cyclic code. Now for the cyclic code properties, for the properties is that as C, that is the cyclic code, is an ideal over Galois field Qx. X is the variable term and Q is the what is the Galois field value will be. So that will be fully divided by of x to the power of n minus of 1. There exists a unique monic polynomial of minimum degree gx, which is called the generator polynomial. Because if we able to identify the generator polynomial, that time we can got the code word also, because generator polynomial will be useful for the generator matrix, and from the generator matrix if we multiply with the masses, that time the individual message what with the code word you can able to identify. So this is important one for the generator matrix identification. So generator polynomial can be got it by using the minimal degree, and that one also a unique monic polynomial. Okay, and this one for the g as a given as a form of g0 as a suffix plus g1x g2x square up to gr x to the power of r, and should be remembered that due to the reason of monic polynomial, z0 and zr should be equal to as a value of 1, and it will be little bit remember also at the left hand side it will be the lower degree, that is the minimum 1 degree, and here at the right hand side will be the maximum degree. Now check that there an example is given to you how to identify this is an monic uh, or monic polynomial. Let there an example is given for the x variable. Fx is equal to 3 plus of 7x plus of x cube plus of 5x4 plus of x to the power 6. If we individually check the coefficient, that time first one is given as a 3, for the second one this is 7, this is x cube is this is also 1 5. So here highest one value is here 7. So you can consider this is a Galois field 8 is present on there, because for the Galois field 8 the variable will be from the 0 up to this is 1 2 3 4 up to this is 7. So here this is 7 is given on there, so this is 0 1 2 3 up to 7. So if you consider 0 where it is present, for the x square, for the x square in this position if you think, so here 0 into x square is given to you, and if you consider for x to the power of 5, so this is plus of 0 into x to the power of 5. So here 0 coefficient is also present on there. So Galois field 8, the reason is that the coefficient for the individual element will be in between 0 up to 7. So this is the Galois field 8, and this can be written down as a Z, at this one will be written as a GF within bracket 8 and within third bracket of X, and that one will be defined as a f of x. So this is the ultimate equation, and that one is, in this example, this is given as a 3 plus of 7x plus of x is cube plus of 5x is 4 plus of x to the power of 4, and this is a monic polynomial. Why this is monic polynomial? Because the highest degree which is given in this position here 6, here the highest degree their coefficient is 1. So for the highest degree is 1, that time that kind of polynomial will be defined as a monic polynomial. So you can able to identify the monic polynomial for any kind of polynomial. Now for the second property is that every polynomial in C, that is the cyclic code, can be generated by the generator polynomial. Already I told you that for the C, if you want to know, that time it's just multiplied with the masses and the generator polynomial, because we know that for the matrix form this is C is equal to, this is masses, or sometimes it is defined as a d into of, this is Z vector. So this one is repeated in this position into the form of the polynomial one. So here Cx should be uh, the value of multiplication value of mx into g of x. So I think this is the second property able to understand. Now for the third one, as the code polynomial Cx will be of degree n minus of 1, the degree of the generator polynomial gx should be r n minus of k. Okay, r is equal to n minus of k. That means how many number of redundancy bit you have to record, that one will be defined the generator polynomial as a degree form. That is the if you write down in this form equation, that time in this case this is 6 is the highest degree. If you write down into the form of the gx, that time the maximum degree for the x will be as the n minus of k. Fourth one is that the generator gx is a factor of x to the power of n minus of 1. This will be should. In case of binary code, as addition and subtraction operation are the same, because for the addition or subtraction, let this is the 0 for the binary case, 0 and 1, these two are the state. So if you add with the 0 as a 1, that time the value will become as a 1. If you add with the 1 again, the 1, that time the value will become as a form of 0. So this will be just rotated as such. This will be rotated as such. Now, if you subtract by using the binary form, let this is the 0 and this is the 1. If you subtract 1 from the 1, so the result will become as a value of 0. From the 0, if you subtract 1, that one, the value will become as the again value of 1. So here also the value will be rotated within the 0 and 1. So in this case, if anywhere the minus 1 is given to you, that means it can be treated. This is also the plus 1, and for this reason there's some example is given to you, so you can able to understand what will be there. So for the fourth part, again I just repeat that the generated gx is a factor of x to the power of n minus of 1 in case of binary code, as addition and the subtraction operation are the same. The generated gx has to be a factor of x to the power of n plus of 1. So both will be defined the same thing. Now take an example for easy understand. Consider a cyclic code of length is 7. Okay, so their n is given to you as a 7. So obviously the factor form will be the x to the power of n minus of 1. So n is there 7, so x to the power 7 minus of 1, and this is the binary form. The example is given, so it can be treated also x to the power 7 plus of 1 from the property of 4 in there. The question is that consider the cyclic code of length A7 to obtain the generator polynomial. We have to identify the generator polynomial. So initially, for this term, we have to identify the factors. So factors are 1 plus x. These are the factor 1 plus x, 1 plus x plus of x cube, 1 plus x square plus of x to the power of 3. So these are the factor, not important in here how you got the factor one, but these are the factor in this case. If any extra option is given to me, then obviously I will discuss about how you can able to factorize that particular element. Though we in this case just memorize that x to the power 7 plus of 1, the factor form will be as form of 1 plus x multiplied with the 1 plus x plus of x cube put into of 1 plus x square plus of x cube. So if you check for the property number 3, so here it is given that for the gx the degree should be r, and that one value is the n minus of 1. So if the n is given to as a 7 and the masses is the 4, that is k is equal to 4, that time r value will be 7 minus of 4, so this will be 3. So you have to check that which one factor has the highest degree is the 3, and obviously that one will be a monic polynomial also. So in this case, there we can consider this one and this one, not the 1 plus of x. So these two, that is the 1 plus x plus of x cube and 1 plus x square plus of x cube, can consider for the generator polynomial of a cyclic code. Check that this is given to you. Look that here it is generator polynomial for the 7 minus comma 4 cyclic code. We can either use 1 plus x plus of x cube plus of 1 plus of x square plus of x cube as the generator polynomial, as both are have degree as 3. Okay, basically there are two types of cyclic code. Initially we discuss about today for the systematic cyclic code. For the systematic cyclic code, from the code word we can easily differ which portion is the data bit or masses bit and which portion is the redundancy or the parity bit. So if for the code word is given as the n, from there you can easily able to identify this is the parity bit, and the another portion would be defined as a masses bit. You can consider the LSB side as a data bit for the k bit form, and the MSB side can be considered as a n minus of k bit for the parity bit. Not necessary as such, but you can consider this one. So this is the form of systematic cyclic code where you can differ so easily. And for the non-cyclic code, it is defined as a form of, for the non-cyclic code, it is not easily able to identify the parity bit and the data bit so easily. So that one will be defined for the non-systematic code. Okay, sorry, today we discuss about the non-systematic code form. Okay, next we discuss the systematic cyclic code. So the question is that or example is given that here consider a 7 comma 4 cyclic code with the generator polynomial is given as a 1 plus x plus of x cube. Already we know that for the 7 comma 4 their polynomial can be considered for the generator as a 1 plus of x plus of x cube or 1 plus of x square plus of x cube. So in this case it is considered as a 1 plus of x plus of x cube, and obtain the code polynomial in the non-systematic form for the input sequence 1010 and 1100. So initially I have to identify the masses polynomial and also the generator polynomial for representing the C of x, and which is the property of, we are following the property of 2. Look at the following property. If you know the generator polynomial and the masses polynomial, if you multiply between them, then you can got the C of x. Okay. So initially you have to identify the masses polynomial, and for the first masses is given to you as a 1010. So I already told that the masses will be write down as such. In this case, as a LSB side will be the highest degree and the MSB side will be the lowest one degree. So it is can be defined as such. Here I can zoom, so I think it will be easy for understand. Also look at the position I just written as such. Here the position for the one we just identify. For the one it is position is 0. For the 0 position this is 1. For the third position it is 2, and this is the fourth position. So at the LSB side the position is the maximum one on there. Okay. Now it can be write down. This is the into the x polynomial as a vector, as the variable one. So it can be write down as a 1 plus of x square. Here this can be write down as such. Okay, this is x, and for this position this is 2 is the position value, and for this region this is x square. Here this is x to the power of 0. That means this is the 1. So in this way mx can be write down as such. Now, to get the value of Cx, the polynomial of the code word for the masses of 1 plus of x square for the polynomial, you just multiply these two. Which two? Gx polynomial will be multiplied with the mx polynomial. If you multiply these two, the result will become as a form of this one, this one. That is the 1 plus of x plus of x square plus of x to the power of 5, and we already know that their number of position is 7. Okay, because the code word length is already told you that this is code word length is 7 on there. Okay, so you have to remember this one. So the position will be for the 7 position will be total 6. So this is position number 0 1 2 3 4 5 and lastly 6. Now check here for the polynomial which one you got it. So first there it should be 1. For the second x is present, so this is also 1. For the third x square is present, so this is also 1. 3 x to the power of 3 is not present, so it will be 0. X to the power of 4 is not also present, so this is 0. X to the power of 5 is present, so this is 1, and x to the power 6 also not present. So these are the code word for the masses which is given to you. Now another one, same kind of formation. The message bit is given to you as a value of 1100. So this one can be write down as a 1 plus of x, because for the initial this is the x to the power of 0 plus of 1 into of x to the power of 1. That means this will be 1. So message polynomial can be write down mx is equal to 1 plus of x on there. So what will be the code word polynomial? For the code polynomial, it will be follow again the formula, that is the C of x equal to mxzx. So if you multiply these two by using this two polynomial individual one, then the product will be as a result of this one. I think here some little bit notation you have to record. If you multiply, that time this is x, and here also x will become, okay, the same thing. And you already know that for the binary form, this is 1 plus of 1 is what happened. This will be uh, for the AND operation point of view. So that time for the XOR case, its value will be 0 or 1. What will be? Uh, Take an example for the AND form. So it will be value will be x on there. Okay. Again, I just repeat that x plus of x. If we added these two, so what will be the value? This will be the 0. Okay. For this reason, this is x is not present on there. Um, I think it is not able to understand to you because I also not explain properly maybe. So here 1 plus of x is multiplied 1 plus of x. So initially 1 is multiplied the 1 plus of x plus x is written this one as such for the 1. For the x it is x into of 1, so this is x, then x into x, so this is x square. For the x into x cube, so this will be x to the power of 4. So ultimate equation is coming after multiplication is this one. Okay. Now here the one you just write down, and x is 2 times is present. X is 2 times is present to you. X plus of x. So if it is x is present 2 times, so there for the binary operation point of view. So x if you just common on there, that time 1 plus of 1. So if it is 1 plus of 1, that time what will be the mod 2 addition? For the mod 2 addition, it will be 0. So if it is 0, then x dot of 0, which is common on there, let this is the x into so this can be x into of 0. So ultimately x term will be omitted on there, and for this reason here x is omitted. So this will be the ultimate equation. You got it on there. So this is the generation of the non-systematic cyclic code. Okay. And G0, G1, G2, Z3, G4. In this case, G4 is taken. It may be up to the G is to N. And here the XOR operation is applied on there. A side is defined as a shift register individual one. Look that message bit is directly come through the G0 to the first is a shift register, and the first shift register output is stored with the uh, product of M into of G1 to get the SR2 position output. So this is the general formation for the non-systematic cyclic code. So take an example, it will be easy for the understand. For the previous, there the generated polynomial is taken as a 1 plus of x plus of x cube. So in here z0 for the 1, z0 is present. If you think for the z1, this is x, so this is present, but x square is not present, so g2 is omitted on there, so g2 is 0 on there. G3 is present, so the G3 is 1 on there. So for the G2, there no XOR operation is applied. Here XOR is not present in between V1 and V2. Here V0, V1, V2 um, individually define the shift register on there. Okay. The message is coming as a form of for the first one. This is the 1100. So this is the input is given to you. This one is the input. We are interested to identify what will be the output for this case. Here C0 is defined for defining the value of V0. For the C1 is defined for the V1. For the C2 it is defined the value of V2. So initially the input is 0 on there, as you see when you are not applying, and then this is the 0. This is the shift is not occur on that time. Okay. Now if you time flow, if you look on there, that time the first data will become for any as you see, this is the box you are applying the non-systematic cyclic code as the input in this position for the left hand side. So in this position, first value will become as a form of 0 because the 1100 first value is a 0 on their LSB position. So here this is 0. Now second one also this is 0. So you have to put as a 0. Third one is the 1. So you put a 1. Fourth one is the 1. And the remaining again apply the 3 because we are interested to get the ultimate output on there. The total 7 massive bit you have to apply for the generation of the code word, and for this region total 7 shift operation you have to do. So for this region there are 7, that is the remaining of this one here extra 3 bit you just add as a 0 on there for getting the ultimate output as a form of the code one. So in here to get the value of v0, to get the value of v0 mx, so this is mx will be directly come in this position, so v0 will be reflected v0 this one. Okay, now if you consider for the c1, that time the output of the v0 for the previous state with also the g1, so here this will be depend on the 0 to get the value of 0 this one, it is the depend on the c0 and also the input. Okay, so 0 and 0 is our operation, and that time the result is 0 on there. To get the value of v2, or this is also c2 in this case, to get this one, that time what happened, this will be depend only on the previous value of c1, so here 0 will be reflect in this position. So check each and every cases. Let we are considering this row position, this row position. Okay, so here initially we just take that how you got the value of c0, why it is come as a value of 1, because this is depend for the v0, this is depend directly with the m. So here the m is 1, and for this region it is come directly as a 1 on there. If you in this position this is 0 or 1, what will be, where for the v1 is depend on the previous value of v0, that is the c0 and also the input. So 1 and 0, what will be the output, 1, 1 and 0 output is 1. So this is as such. For the 0, why it is come as a 0, because this is depend on directly for the value of v1, not depend on the input. So v1 is coming at the output value of 0 in this case. Okay, so how can you got this one as a value of 0, because due to the reason of previous one and the input 0 and 0 is 0. Why it is come as a value of as a 1 in this case, because the previous one is the 1 and for the c0, and this is 0, 0 and 1 is 1 on them. So by this way you can got the ultimate value in digital one, and the c1 also got it in the same way, because c1, for the c1 it is depend on the input and also the v2. So if you want to get the value why it is come as the 1, so this will be depend on the v2 previous value of v2 and also the input. So in between you have to do the XOR operation or mod 2 addition, then the output will become as a 1 on there. Okay, if you consider for this one why it is come as a value of 0, so this is reason for the previous one value for the c2 and also the input, both are the 0, so mod 2 addition will be as a value of 0 on there. So you can got it the code word for the masses of 1100. Look that this is the table also given to you. You have to check from low to upper side. So this is 101100. So this is the code word for the masses 1100. From the matrix you can also design this one. So here G matrix, how can you got polynomial, you just check, this will be 1101. Look that this is 1101 and remaining are as a 3 value will be 0. Why? because x to the power 4, x to the power 5 and x to the power 6 is not present, so it will be as a coefficient value of 0. So first row you can able to write down, this is the first row you can able to write down from this expression. And then due to the reason of this is a cyclic code, so generator polynomial will be shift one after one. So here 0 will be for the LSB bit, 0 will become as MSB position. Now the present value will become as a 0 1 1 0 1 double 0. Again you just rotate this one, that time the value will be 0 0 1 1 0 1 0. In this way you can got the matrix. Now the question is that why it is only the three times you have to do to get the generator polynomial, because they are the generator polynomial, their rule will define the how many number of masses you are applying on there. So this is the 4-bit masses is applied, for this reason 4 you just applied on there. Now check that, is this as a form of the IKP or P of IK, that is the systematic form is given to you or not. And if you check properly, then obviously this is not into the form of the systematic, so you have to convert into the systematic form. So this side for the right hand side is defined here is identity matrix, and this one for the parity matrix. So now the G is converted into the systematic form, and if you multiply it with the masses bit with the generator polynomial into the form of the systematic, then you can got the code word, and it is same as the already you got it from this table. So I think each and everyone can able to understand what is the way by which you have to do the non-systematic cyclic code, and what would be the diagrammic point of view, what will be the form or circuit diagram for the non-systematic cyclic code. Next day we again meet, and we will discuss the another one portion for the systematic code, for the cyclic code. Till I have to say good day and bye.